morning, guys. Welcome back to Velocity Garage. It's first thing in the morning, so I'm a little tired. I got a few things I want to do on the Celica today, so I'm pretty excited. It's the first day I've had a chance to actually work on this thing in probably a month or so. So I'm a little excited to get this work done. I'm hoping to get this thing running again by the end of the day, and so let's get started. So here's the deal. Today I'm going to do some work on the gray Celica. It's all fuel related. So what I'm going to be doing today is comparing fuel pressure regulators. The stock fuel pressure regulator, I'm not sure if it's a rising rate fuel pressure regulator. So this is the factory 5 SFE fuel pressure regulator. Fuel goes in here. Fuel comes out at this banjo fitting, and then vacuum boost reference would go in the top here. So the question is this boost reference? I have no idea, but we're gonna find out. I did some research on forums, never really found a straightforward answer, so I'm gonna find out for myself today. This one is a 3S GTE fuel pressure regulator. So obviously this one should be a 1-to-1 rising rate fuel pressure regulator. So for every pound of boost, it should raise the fuel pressure the same pound. Anyways, so 3S GTE one, fuel comes in the bottom, fuel comes out the side. That's the opposite of the 5 SFE. And then you have your vacuum boost reference on the top. So put side by side in the direction that they flow fuel. Differences, similarities, they're pretty close. I mean, fuel pressure regulator is a fuel pressure regulator. The question is, does it adjust fuel for each pound of boost? All right, let me show you my setup I got here. This is how I'm going to be testing the fuel pressure regulator. Now, I don't recommend this. This is not at all safe for fuel. I am actually using water to test all this stuff, so I'm sure the actual measurements will vary between water and fuel, but for safety reasons, I am not using gasoline because I don't want to catch on fire today. Okay, so everything's been set up for the first test, which is going to be testing the factory 5S fuel pressure regulator. So just give you guys a quick little rundown of everything set up here. What I have is the factory Celica GT fuel pump ran through this hose to just some fittings I had laying around. This gauge right here represents the fuel pressure. So as the fuel pressure increases, this gauge will increase. We have the factory fuel rail attached to this inlet, comes across here. And then on end, we have the factory fuel pressure regulator. So that's my setup. I don't have the banjo fitting and hose that comes out there, so it should just hopefully land right in the bucket. All right, so that's the pump and the regulator, the rail setup. So how I'm going to test this is I have a pump for testing the cooling systems. I just pulled the hose off. There's the other end. So I've just pulled the hose off of this, and I've put a smaller hose on it. And what this is going to do is going to press right on there, and this is going to simulate boost pressure, because I can very, very accurately increase the increments on this. So it should be pretty accurate. Then just for kicks, I've got a vacuum pump here. It doesn't work very good, doesn't hold a vacuum, but it creates somewhat of a vacuum. All right, let's get started. Let's test the first fuel pressure regulator and see where it's at. All right, so as you can see, it's about 45 psi base pressure. And then I'm going to apply a quick vacuum. I'm going to try 10 inches of mercury. So it doesn't really hold a vacuum. But as you can see, fuel pressure is going down as I increase vacuum. So now it's time for a boost. Alright, let's get this done before it starts spraying all over the place. Alright, so the base fuel pressure about 45 psi. So if I take this and raise it to 5 psi, should be at 50. Okay, it is. So if I raise it another 5 psi, we should be at 55. And it is. Just for kicks, let's raise the fuel pressure to 15 pounds of boost, and it should be at 60 psi. And it is. So that's very interesting. I was not expecting the 5SFE fuel rail to be boost reference. That's very interesting. And it's back down to 45 psi base pressure. So let's try this again. 5, boost, 50. 10 is 55. And 15 pounds of boost is 60. So, alright, now we know that the 5SFE fuel pressure regulator is 1:1. Let's still compare it to the 3S GTE and see what the differences are.
Underwater tropical storm in her hair. If you find it, there's a weaver cobras with Medusa's mind control in her hands. If they touch you, like my descendants' victims, they will turn you to gold. In her words, like Achilles, will trick you into letting them right into your soul. She's hot.
So now we're going to be testing the 3S GTE fuel pressure regulator. Now right off the bat, there's a difference. It's got a 40 psi base fuel pressure rather than the 45 psi base fuel pressure on the 5S. So what I'm going to do, first test the vacuum, as it should already be set up for this. And gonna try to get another 10 out of it. And it goes down. So there you go. So it does go down with vacuum. Coolant pressure tester out. And let's do 5 psi. So 45 psi, a little over. I'm a little over, but close enough. So then let's do another 5 psi, should be 50. Right on. Alright, another 5 should give us 55. So we're right on again. And then if we do another 5, should max out at 60. So you can do 20 pounds of boost. It's a lot of boost. Anyways, so it is a 1:1 rising rate fuel pressure regulator. So both of them are. The only difference is with the 5S, you have a higher base fuel pressure. So very interesting. All right, so what I've learned here is that the factory 5S FE fuel pressure regulator is adequate for turbocharging a car. Everything I just did here basically tells me that my fuel pressure regulator is good. So there's no point in drilling and tapping and changing the fuel fuel regulator around, because what's in the car right now is capable of running turbo. All right, I want to show all you this. This is my BGB for 91. So, all right, so according to this book, it says that the fuel pressure disconnected for the 5 SFE should be 38 to 44 PSI. What we found was a base pressure of 45 PSI, and that's for the 5 SFE. So its OEM spec is 38, 44, we're at 45, and from the 45, it rises up continuously per pound of boost. So, or per 5 pounds of boost is what I actually tested. So, let's go over to the next one. It's the fuel system for the 3S GTE. It says with the vacuum hose disconnected, it should be 33 to 38 PSI. And what we found was a base pressure of 40 PSI. It's a little bit higher than what it's listed for, but it's still close enough, I suppose. I could have tested another fuel pressure regulator, but the truth is that this isn't, you know, a complete 100% accurate test. I mean, there's things I don't have set up that could, you know, in fact, change the results. I don't have fuel lines. I don't have a long feed fuel line. I don't have a long return. I'm not running the proper fuel, or you know, I'm running water instead of fuel. The viscosity is different. So there's whatever. This is just to give me an idea of the rising rate, but according to the book, this is what pretty close to spec. So, all right. The other thing I want to show you guys is in this book, if you go to fuel pressure regulators, they actually break down the different regulators, and I've lost it. Here we go. Here's the 5SFE fuel pressure regulator. There's a spring. You have your vacuum in, check valve, fuel in, fuel out. So you can kind of get an idea of how this thing's built on the inside. Now if we compare it to this one, oops, there you go, found it. It's a little bit different. There is a difference between them. I mean, obviously the fuel's coming in differently and going out differently. Definitely a different setup. It looks like there might be a check valve in here. Well, that should be a check valve in there because that's where the fuel's going in. I'm not sure. That looks like a check valve, but that would not be, in my mind, that wouldn't be right, that there's a check valve with the fuel going in, because that's going to just block it. But anyways, this is just to give you guys an example. You know, compare the internals. I showed you guys what it looks like from the outside, so just using this book to show you guys different from the inside. And the book doesn't have any clarification on testing to see if, you know, if it's still a rising rate or not. I didn't know if it would show like under X amount of pressure it should raise this much. However, it doesn't have that. I thought it'd been cool if it would have, but that's probably not necessary. So, all right, that's it for this. But if you guys have any questions on the information here, or how I set this up, or any just general questions about the fuel rails differences, I'll be happy to try and help you guys out. So, don't think I'm forgetting anything. I had a list of things I wanted to go over. I think I hit everything for this one. You guys watch out for my next video. I'm going to go over everything I just did all this for with the new fuel injectors. It's going to take a little bit of work to get those working, so I'll have all that described in my next video. So y'all take it easy, have fun, and see you guys later.